just before our last class, we were drawing the atom. Remember? Which atom was it? Do you remember?
We drew a lot of items.
Can we use the
iron? We were drawing iron. Okay? Now, we're drawing these atoms so you can see how the electrons are arranged around the nucleus.
You're just adding stuff.
All right? We're drawing these atoms so you can see how the electrons are arranged around the nucleus.
I have to.
The electron configuration. That's the goal here. Now, don't get overwhelmed if the diagram looks confusing, because remember, we have to go fast because this takes longer than 15 minutes. So, yeah, here we go. Ready? Here's the nucleus, and then there's 2 electrons in a small spherical shell, right? And then there's 2 more electrons in another spherical shell. And then there's a total of 1, 2, 3, 4, 5, 6 electrons, right? And then there's 7, 8 in the next shell.
And then
there's
9,
9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Is that a magic number, 18?
No. Yes.
Yes, it is,
Argon.
right? Argon. So there's another noble gas. And then 19, 20 should be the third S row, right?
Yep.
19, 20. And then 21 is what?
Scandium.
21. What's number 21? Scandium. Scoot over, Tam. Makes a little bit of space.
Tim, you can sit right here.
21 is scandium. And it's in one of these, watch this craziness, one of these D orbitals.
Yeah, a little crazy.
21, 22, 23, all right, 24, wait,
Are you counting by twos?
yeah, how far are we now? Where's 24? How many does iron have?
Iron's 26.
24? Or 26? And we're at 24 now.
Cohernium.
And then
So just
each
one
one of
more.
these can hold 2, so we just need 2 more. 25, 26. So we got there. So this is what iron looks like. See? Can you see all the electrons?
Yes.
Yeah.
Kind of a what?
Big thingy.
Atom.
A mess. Right? This is a mess.
Wait.
You can't tell what's going on. You can't tell what's going on there. What?
It looks better. It looks more organized on the computer.
On the computer, yeah, but still you can't tell what's going on too well because it overlaps so much. So we have what are called orbital diagrams. Diagrams where we plot the energy of the orbital, and we make a little graph here to show us how the orbitals are filling up. Each orbital is represented by just a little line. Okay? So here's the nucleus. Here's the 1s starting over. All right? I just make a little line. And I say, okay, this is the first row, 1, and it's a spherical S. All right? And it has 2 electrons, so I draw 2 little lines there. The next one is bigger circle.
So it's another
It's row what?
2S.
2. So it's 2
And then it's an S.
S,
And then it's a line.
a line,
And then tic-tac-toe.
2 little electrons in that. Okay?
How come last time we put 2 lines?
I did. I put 2 lines in both of them. Because those are the 2. Those represent the 2 electrons.
Why did we go with the yesterday?
Okay. What's next again after the 2s?
3S. 4S.
Okay. I need you guys to focus on your periodic tables for a second here. Okay.
So right now you have
4 beryllium.
4 beryllium. That's right. So you have to look here and see what's next. What is this block here? What do these ones look like?
Those ones are the dumbbells.
These are the dumbbells, right? Called the p orbitals.
So
So we've just finished 2s. Now we're going to go into some p orbitals. How many p orbitals are there? Well, there's 6 electrons, 3 p orbitals.
Yeah.
3 p orbitals. And what do the p orbitals look like again?
Dumbbell.
Dumbbells like this, right? 1, 2, and then one coming out at us in the z-axis. So, what row are these p orbitals on?
Row 2.
They're row 2. So we got 1s, 2s, and now we do 2p.
Wait, why is it still 2? I thought you were going 1, 2, 3, 4.
Well,
No, that's
we're
going by
giving it a
rows.
number based on the row that it's in.
1 row. 2 row, but it's still on the 2 row.
Does that make sense?
1, 2,
So here's 1,
1s.
S,
Kills for them.
2,
And 2
S,
S, but
2
then
P.
2 P because it's still in the same row.
because we're still in the second
Oh.
row.
But why doesn't, if helium's in this block, oh,
Okay,
but
now
it's
helium
not.
is the exception again, right?
Okay.
It's a weird
Helium
scenario.
and nitrogen are the
Hydrogen. All right, so 2p, how many orbitals did we say? 1, 2, 3. All right. How many electrons in each orbital? 2. 1, 2, 1, 2, 1, 2.
will they ever not have
However, when you fill up orbitals, they actually fill up like this. Here are the orbitals. One goes in each, and then after they go in each, they start getting paired up.
You will have not as many if you don't have enough.
All right. Right now, if I were to stop, which atom does this represent?
That represents neon.
Neon.
Oh yeah,
Neon.
neon. It's a noble gas.
It's a noble gas.
Why not gas?
All right. Do you guys on the couch see this?
Yeah.
This 1s.
Look, what a helium
1
is.
means
It's
what?
a
You guys know what the
dot.
1 means?
Whoop.
It means the row in the periodic table.
Helium is just a dot.
The S means that it's a spherical shaped one. And this box is where the spherical shape, this represents the spherical shaped orbital. These little lines right here represent the number of electrons that are in the
Kind of
orbitals.
complicated because, you know,
Right?
what they have.
All right, excellent.
They're not even-
Okay, 1s, 2s, 2p. What's next after 2p?
3s.
3P.
Yes, because after we're done with the 2p, we're at the end of the second row. So now we have to go to the third row. Right?
3S.
3s.
3P.
All right. So now I'm going to write 3. How do you write a 3? Right? So 3s. There's the 3s. 2 electrons. And then what's after 3s? See, here you can follow along and find that it goes to the 3p's. So after 3s is 3p. And 3p is 3 orbitals, right? They feel like this. Kim, tell me what's after 3p. 1, 2, 3.
After 3P is ours.
4s, that's right. 4 because what? Why do we say 4?
Because it's in the fourth row.
Fourth row. How many orbitals are in 4s? There's just one 4s orbital and there's 2 electrons in it. All
But
right?
then don't you have to do another?
No, then you do the P's, then you do the D's, or the D's, then P's.
Now, that's what's interesting.
Wait, what are these blue ones again?
Those are D's. So those are next, aren't they? Next is a D section. Now, the D's have a little bit of an exception associated with them. This row, even though it's in the fourth, we call them the 3Ds. The 3Ds. Okay? So, this is our 3Ds
3Ds.
because in energy, they're actually lower than the 4S's. 3D, is that a D?
It's a B. There you go.
3Ds. Now, how many orbitals are in this 3D subshell here? How many orbitals do you think there are in this 3D subshell?
10?
There's 10 electrons, so how many orbitals must there be? 5. 5 orbitals. 5 orbitals. Here they are. 1, 2, 3, 4, 5. 10 electrons. Because there's 1, 2, 3, 4,
Oh, 'cause they're
5,
different,
6,
yeah.
7, 8, 9, 10 different electrons that are
And
filled along
protons,
that.
don't forget we're adding protons too.
Okay, so
No, we're not.
10 10 electrons could fit in there, but how many do we actually fit in there if we're just going to go to iron?
1, 2, 3, 4, 5, 6. Just 3 orbitals.
So we just, no, well, remember how we fill orbitals? We
Oh,
have
yeah.
to fill them like this. 1, 2, 3, 4, 5. But then the sixth one goes where?
The first.
Back into here. Okay.
That's iron.
All right. This is iron. Ta-da! We made a
What's that?
atom that or a diagram that represents iron. Yeah.
How come I wrote 5?
No one remembers it should be over 3.
5 what?
Not even
Oh,
118.
because there should only be 3 because there only need 2.
Yeah.
All right. Because you only need 4 electrons. You mean? Because when you fill orbitals, they don't want to pair up until everybody has one, and then they start pairing up. Does that make sense? That's called Hund's rule.
Like,
You
these
actually
whole
realize
zaps the
that
hydrogen, just one
electrons will
hydrogen.
not pair up in orbitals until each orbital has one. Okay? So this is represented again by this. What? Tilde. What are we talking about? Huns. H-U-N-D. Tilde Hund. All right. So this represents this, correct? But this isn't something that I can look at and say, "Aha! Now I know." Right? But this I can look at and say, "Aha! Now I
That's iron.
understand how the electrons are confused."
I'm like, oh, that's
I can't
iron.
even see the electron.
Yeah.
I mean,
Okay.
how are you supposed to tell any of the metals one way?
And now we're there.
went up the ladder.
Welcome, everybody. Welcome to the point where you can look at this and say, "Ah, that's why iron does what it does."
That's
Okay.
why it only likes to lose.
Here's what iron will do. Wait. 3p, yeah, 4s, 3d. Here's what iron will do.
Iron's okay with losing 2 when it comes to
He also climbed up the ladder. 4s.
Yes.
Because of the 4s.
It loses these 4s electrons first. It loses these 4s electrons. By losing these 4s electrons, it's losing this outer shell, isn't it? Does that make sense? And so all the electrons kind of compress down a little bit. So by losing these 2 electrons,
It's more stable.
it makes a +2 ion, correct?
Yeah.
And iron attains a little bit of stability.
Enough and it's happy.
It's happier.
Happy.
When we're just using plain metal, like iron, is it Fe plus 2?
No, that's just Fe, right? But you leave it out on your counter or you leave it in the backyard or let it get wet and it interacts with the oxygen and becomes Fe plus 2 because oxygen comes and says, "Hey, I need some electrons," and iron says, "I got these 2 extra." And so that's
Is
the
that where
rusting
rust
Yes, that's what the rusting process is.
So Fe plus 2 is rust.
Fe plus 2 with oxygen is rust, so iron oxide, right?
Cool.
Now, did you know that iron also forms, this isn't the only thing he forms, he also forms a +3 ion.
Why?
I don't know, can you figure out why he would form a +3 ion?
What would he lose?
Something from the 3D.
Because 2p?
He says, this little extra electron makes me look fat. If I could just lose this, I would look so much better.
But then, oh yeah.
Doesn't that look nicer? Now this is all symmetrical, instead of having an extra one right
Why do
there.
they have one that is like...
Dad, they have 2
Does that make sense? This is 1,
No, that's a 2, isn't it?
and this one's 2.
No, with those,
Right.
with those it fills
There's
1
2
by
here,
1.
but he would like to lose just that 1, and then just have a symmetrical outer shell.
So what's Fe3 combined? What does Fe3 do?
Fe plus 3 likes to combine with oxygen as well.
But does it create
Is it a different kind of rust?
It's a slightly different kind of rust, that's right. Slightly different kind of compound.
So rust
So it
is
depends on
less
how much
explosive than iron?
Okay, now let's draw zinc. Rust is less, what? Yes, rust is less reactive
Zinc is in...
than iron.
Wait,
However, it's
so
less
zinc is
strong too.
third.
Yeah.
So you can't make a car out of rust because it falls apart easy.
I just like,
So
But
Fe3
there is something
happens when
interesting.
there's more
Here's
oxygen.
something interesting. Aluminum oxide is very
a
stable.
substance that's
Therefore, cans made of aluminum, even if they rust on the outside, the aluminum oxide is stable. So people
aluminum
can still
oxide
drink and
is this
have that
substance
can or
like
that
it's like
car.
coal.
Yeah.
It starts with a C.
My
and
friend
it's
Quickly.
longer.
My friend once told me that if you get a ingot of aluminum, you can sell it for like $40.
Yeah, probably. All right, so now we're going to do this orbital diagram for
But a car is
zinc. Zinc.
Why'd you erase that? We could have just added to it.
Added to what? Oh, really?
Yeah.
Oh, nuts. Okay, let's start over. What's zinc got? How many 1S's?
Uh,
2. How many 2S's?
2.
2. How many 2Ps?
3. No.
Total of 6 electrons. 1, 2, 3, 4, 5, 6. 3 S's?
2,
3 Ps?
6.
1, 2, 3, 4, 5, 6. 4 S's?
2,
3 Ds?
10,
Wait, no.
5, 10.
10.
It's full.
10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Zinc.
All right, so zinc, what kind of ion do you think zinc will form?
Where
Zinc
is
will form
it?
Zinc plus 2.
Where's zinc at? What
It's
number?
number 30. Yep.
Isn't it a no,
It's
yeah,
30. It's 30. 30.
It's number
30.
30. Is that right?
30,
Everybody see
yeah.
30?
Yep.
All
So
right.
it's more stable
Very
than
good.
iron.
Perfect.
So it's more stable than iron.
It's got some stability
I'm
associated
saying
with
it's
it.
more stable than iron.
It's not necessarily more stable than iron, but it only likes to
It
form
doesn't look
one
that
kind of ion.
tasty.
Ion. It only likes to form one kind of ion.
Zinc plus 2.
Zinc plus 2. That's right. What is happening when it forms a zinc plus 2
It loses
ion?
its 4 S's.
It loses these two 4s electrons and forms a plus 2 ion. It doesn't form a plus 3
What about
because it's happy with its symmetric outer shell.
so?
Does that make sense?
So if you had cobalt, it would lose. You could get a cobalt plus 4.
Yes, you could get a plus 2 and a plus 4.
Where's
What about on
cobalt?
the second row down?
Second row downs follow the same pattern. They're losing a 5s, right? 5s2,
And
and then the 4ds kind of a
and similar way.
Yes,
Would it be
Fran?
happy losing?
4P.
Yes.
Would it be happy
4p.
losing?
1, 2, 2, 3, 4. You got
you got
gallium to krypton is 4p. All right, gentle people.
Also the
Be
same way.
kind. Rewind.
Chromium would. Similar way.
Root